Hey, so a while ago I wrote a program to rasterize a font, and what this means is basically take a piece of text and the font file to render the text in and figure out from that information which pixels of the screen sort of fall into the boundaries, the outline of like the letters, so you can show the text on a screen. Um, so I made that program a few months ago, but this time I'm going to do it again and show all of you so that you can follow along. Um, so yeah, we're going to do this in TypeScript, and I'm going to create the project using vite. Um, And I'm not going to use any framework such as React, but I will use TypeScript. All right, cool. So that's going to be creating our starter project. And the other thing is we need a font file to render. So yeah, let's get a font file. The one that I've been using is Noto Sans. So yeah, let's get this font. And I think there's like different versions of it, and I think this one is variable, which is like too complicated for our needs. We just need like a basic font file. Actually, I think if we download this, then we'll get the regular one inside of the zip file. Oh yeah, under static, then we'll get like yeah, Noto Sans regular.ttf. Okay, so yeah, the program that we're about to write, it's going to look into this file to figure out, yeah, exactly like which pixels to turn on to make text appear on a pixel grid. So yeah, let's take this file. I'm going to copy it and paste it into the project that we just created. I think we should put it under assets so that, well, okay, I don't know. Actually, we'll figure it out. Okay, so we have the font file in our project. So we'll open the project. And we'll run it, and we should be able to see our blank, well, it's not really blank, but yeah, the starter project that we generated. So yeah, there's a lot of stuff here that vite created for us. We don't need all of this, so I'm going to go into main.ts and just delete it all. Okay, so now we just have this blank page, and in index.html we have pretty much just a div called app, and then it includes our script, our TypeScript language script. So we need to get information out of this font file, right? So let's first, let's first try to get this file in our code. So we want to fetch it. Let me open the terminal since I'm going to want to console log a few things, probably. So yeah, let's fetch. And I think it was Noto Sans regular.ttf. And I think this like returns a promise or something, right? Yeah. Well, okay, actually, I'm gonna probably do this in an async function so that I can use await. And then we'll call the function. And then, okay, let's save the response here. or let's console.log the response just to see what we got out of here. Okay, cool. So we got a response. Actually, I'm not entirely sure that by requesting this path, will it fetch stuff out of here? I guess it said 200, so it was okay. Yeah. Let's. Okay, so we have bytes and we have array buffer. Okay, so I think with an array buffer we can do some interesting stuff. Oh, we need to call it. It's only 441 bytes. Okay, I think something went wrong. Because I'm pretty sure the file was much bigger than 441 bytes. Yeah, it was 629 kilobytes, right? So, oh wait, was it supposed to actually be in the public folder? Let's see if that works. Oh yeah, there it is. Okay, now it's 629,000 bytes. That sounds more accurate. Oh, okay, and then we can actually see the individual bytes inside the file now. So actually, let me just log a few of the bytes in the file just to make sure that we can see them. Okay, I'm going to look up the array buffer API because I don't remember exactly. Okay, array buffer. Oh, I guess, do you have to like create a view into the array buffer? Okay, sure. Let's just do this just for now, just to see if we got like correct data in the array buffer. Okay, and then I'm pretty sure we can just, yeah, we can just like get some bytes out of here, or I guess not bytes, but integers. If we want bytes, then we could probably say uint 8 array. Okay, so we got some bytes. From what I've seen before, I'm pretty sure that these are the correct bytes that we would expect from a TTF file. So yeah, let me show you what sort of information we can expect to find in this TTF file here. So there's like documentation for the TrueType font specification. And yeah, this is some documentation from Apple where it tells you basically everything that you would find in a TTF file. So the stuff that's immediately relevant will be, I guess. Okay, yeah, so this this tells you like the first thing that shows up in the file, the font directory. And the first thing that we found was a 4-byte value. And we found the bytes in this order 0, 1, 0, 0, right? And yeah, it does say that this value in big endian, so like the most significant byte first, 0 and then 1 and then 0 and then 0. Those are just kind of like a magic number that you would find in the scalar type. So yeah, that seems pretty good. So yeah, let me tell you about like what else are we going to find in this. So basically the font file tells us the shape of every character. So like it tells you what an A is shaped like and what a B is shaped like, what a $sign is shaped like, and what like any other character that you might want to display is shaped like. And it contains an outline for each of those characters, and those outlines are called glyphs. So the font file is organized into a bunch of tables, and each table has like its own documentation. But I'll tell you the most interesting ones. There's the glyph table, spelled GLYF. This actually contains the shapes. So this has probably the most interesting information. So it's just glyph after glyph, and each glyph has, you know, x coordinates, y coordinates of like basically shapes. We'll get into this in more detail later. But there's also the loca table, and this basically tells us where do we find the glyphs in the glyph table. So, you know, if you want to find glyph 0, it gives you like some offset. And if you want to find glyph 1, it gives you some other offset. So this tells you like where in the glyph table you find the shape that you want to render. And then there is CMap. Where is CMap? Okay, so what I referred to earlier was glyph numbers, right? So glyph numbers are like glyph 0, glyph 1, glyph 2. But how do we know which character is which glyph number? Every character has some kind of code point, right? Like in Unicode, there's a Unicode code point for letter A, letter B, lowercase a, and $sign and all of that. But how do we know which glyph index corresponds to which code point? So that's what the CMap table tells you. So I guess to summarize the process, if we had like some kind of string made up of different Unicode code points, like HELLO, you have a code point for each one. The first thing to do is use the CMap table to turn that into a glyph index. And then the next thing is you look up that glyph index in loca to find the offset into the glyph table. And then you go to the glyph table, go to the offset that you just found, and then you get all of this stuff, like the x coordinates and the y coordinates of like all the contours, which are like the outlines of the shape. Okay, so that's like a general, not detailed overview of what's going on in here. But before we can see what's in any of the tables, we need to find the tables to begin with. So yeah, let's start writing the code to look into the table directory, which is, where did it talk about that? Oh yeah, the font directory. Okay, so this is the thing that we saw at the beginning of the file. We have 32 bits, like a 4-byte value for just a magic number. We can just ignore this. Or we already looked at what it was, and it was this number for this file. Okay, the next thing is the number of tables in the font file. And yeah, this is like, you know, these tables, like how many of these are in the font file. So that will be found next. Okay, and then I'm just going to ignore the rest of these since they're not important for what we're doing. So after this structure, we will find, for each table, we'll find a table directory entry, and the table directory entry looks like this. So this tells us like which table it is, the 4-byte identifier of the table. And this is like one of these 4-letter words, basically. And then it tells you like where in the file that you find the table. So you get an offset from the beginning of the file and how big is the table. So with these table directory entries, we know exactly where every table is. So let's try to get that out of the font file in our code here. Okay, one thing that I remember reading about is there's a better way to do this than converting the array buffer into a uint8 array. There was like a data buffer or something like that. Oh, data view, is that what it was? Oh, yeah, here. Yeah, so a data view is something that you can make from an array buffer where you can get all these useful methods, which we want. Like we want to be able to like get a 32-bit integer, unsigned integer, or a 16-bit signed integer, whatever we might need out of this file. So this class gives us some convenient methods to be able to do that. So, okay, let's see. We can basically just make a data view out of this array buffer. And then we should be able to pretty much get things like uint32 at index 0. So this is basically, I'm trying to get this number, which hopefully should be this number. Oh, but we know it's in little endian, so can we make sure to specify that? I think I saw. Oh, okay. There's a little endian argument here. So what is that by default? If false or undefined, a big endian value should be read. Okay, so I don't have to specify it. It'll already be big endian by default. Okay, that's good. Okay, so we got this number. I want to see what it would be in hexadecimal. So to string 16. Okay, yeah, that is 10000. It doesn't have the leading zeros, but it is the same number as this 10000. Okay, so that's cool. So now we should also be able to get the number of tables. So this was the scalar type. We're just ignoring that. But this number of tables we will use shortly. So this is a 16-bit unsigned integer. And it'll be at offset 4 since it took 4 bytes to represent this value. So after those 4 bytes, you get this next value. And that is 10. Actually, no, it's not 10. It's 16, but we printed it in hexadecimal. So, okay, so the number of tables is 16. Great. All right, so now let's get that many table directory entries. So let's put that in a variable. Const num tables equals this. And yeah, so as I said, like after this thing, which is the first thing you find in the file, and how many bytes is this anyways? 4 bytes for this plus 2 bytes for each of those. That's, I guess, 4, 6, 8, 10, 12. Okay, so this whole thing is 12 bytes. So after 12 bytes, we'll be able to see the table directory entries. And each table directory entry is 4 times 4 bytes, which is 16 bytes. Okay, so we'll say table directory entries start is 12, and each length is 16. Okay, so we should be able to get the offset to each table directory entry by doing this. Well, I haven't specified what I is, but that's like the current table index. So yeah, let's get each entry just to figure out where all the tables are. So let's do a loop for let I equals 0, I less than num tables, since that's how many table directory entries there are, and I++. Okay, so we should be able to say this is the offset. I just want to print the offsets just to make sure I'm on the right track. Okay, yeah, so we started at 12 and we're increasing by 16 each time because, yeah, 12 is how far in the file you'll be after this, the beginning part, and then 16 is how big each of these are. Okay, cool. So now we need to get, yeah, let's see if I can print the tag of each table. Okay, actually in TypeScript, I'm not sure if I can convert a 32-bit integer into just like a string that we can read. Or even just like if I get the 4 bytes out of the view, can I turn that into a string? Okay, I'll worry about that later. I'll just try to print the bytes of each one. Okay, so the tag will be exactly at the entry offset. So it'll be the 4 bytes starting from there. Let's try to print those. So we have view dot get. Can we get like a slice of bytes out of this? Let me look at the data view API. Okay, these are only getting like individual values. Okay, I mean, I guess I can just get 4 individual values. Oh, and then I could like convert each of them into a string and then join them together. Yeah, let me figure out how to do that. So JavaScript convert, I guess Unicode code point to string. Oh, okay, so there is just a string dot from code point. Is that different from char code? Oh, this is UTF-16. And oh wait, you can actually just pass like multiple of these. Okay, that's good because I actually need multiple of them. Can you do that with this one? I guess so. I guess the only difference is that this is UTF-16 and maybe this is like full Unicode. I don't know. I think I'll use from charcode because that's maybe less intimidating, but really they should just both work. Okay, so we want to create an array of these bytes. So let me just create get all of these uint 8s. So it should be an entry offset and then entry offset +1 and then +2 +3. Oops, I did too much pasting. Oh, it's not formatting this. Okay, and then you need to add the +1, +2, +3 so that we get the next byte each time. Okay, so we are getting 4 bytes. And then, okay, so what we need is to turn this into a string. So we can pass all of this to string.from charcode. And yeah, there we go. We got all the tags of the 16 tables. There are 16 of them, right? Okay, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. Okay, yeah, there we go. Okay, so we have the tags, and now we can also say, like, for each of them, we could get their offset and their length. So let's console.log view dot, and all of those are u32, or yeah, uint 32. So entry offset plus, I guess one of them was 8 and the other one was 12. So what I'm doing is like, this is at entry offset +0, entry offset +4, entry offset +8, and entry offset +12. Each of them is 4 bytes. Okay, so the offset is at +8 and the length is at +12. So this is the offset. And this is the length. Okay, so now we have the tag of each table, and we also have where it is in the file, the offset, and the length of the table. Okay, that's good. Let's put all of this into a map so that we can easily access it later. So we'll call it the table directory. And this is a map from, well, we'll use the tags as the keys. So it's from string to, well, I'm going to make the type later, but table directory entry. So this is going to hold the, like, all of this information, the offset and the length. So interface table directory entry. The tag will be a string. The offset will be a number, and length will be also a number. So let's make these constants using multiple cursors to make my life easy. Okay, so we got the offset and the length. Oh, also this should be the tag. So we have the tag, offset, and length. And we should be able to just set it in the table directory dot set. Tag is the key, and the value is an object containing the tag, the offset, and the length. And then Okay, now we have, okay, yes, we have the map, and it's keyed by the tag, and we have the offset and length of any table that we might want. So um, yeah, the glyph table we said was the most interesting. The loca table, it tells us where to find stuff in the glyph table, and like, oh yeah, given a glyph ID, loca tells us where to find stuff in the glyph table, and then CMap tells us which glyph ID corresponds to which characters. Cool. So far, we've created the starter project, included the font file, and started parsing it to see the directory table entries. And now we've kind of found where all the tables are. So the next step is, well, we want to get the glyph table, which is where all the shapes of each character is. But in order to do that, we need to look at some of the other tables. So that's where we'll pick up in the next video.